Hey, morning everyone. Okay, so we'd like to share with you the experiences of projects that we're working with Cisco and Deutsche Telekom. This project is currently ongoing, but I think it's an interesting use case, and hopefully we'll see a lot of what we heard yesterday in terms of best practices and things, are reflected in what we've been doing. So this is all about the AUTLAN project. This is Johannes, and my name's Annand.
And we also have the third team member today for our presentation. It's our basically project mascot. We already heard that the team spirit, positive emotions, getting things done is important. So having a mascot helps with that. So can only recommend it.
Okay, so the agenda for today, we're going to talk about the goals that we had when this initiative started. We'll discuss the approach that we look to use, and then we'll talk about the software upgrade use case, and we'll go into more details on that. And there is a demo, and this demo will be a live demo of the actual solution. So we're going to run through the software upgrade use case, but I'm conscious, we've got lunch coming up, so we're using simulated devices. We're not going to sit through an entire upgrade of the switch. We'll talk about some of the CI/CD aspects that we are leveraging as part of this project, and then just quickly, what's the next steps. So this is the current state to the next state. So what we're trying to achieve here is, right now at Deutsche Telekom we have configuration, maintenance, lifecycle activities. These are all performed manually. They're time consuming, they're error prone, and this essentially results in a lot of demand on the network engineering and the operations teams. And then, as a consequence, there's a lot of excessive out of hours work. Maintenance windows are quite often late in the night. So there's a human aspect of this that we often forget. And one of the things that we try and solve with automation is, we're trying to make the business more efficient, but employee satisfaction comes into its own when you can reduce those types of tasks. So where we want to get to, we want complete automation of all the maintenance activities. We want a simplified and improved operational process. So there's no point automating things if it's still very, very difficult to use. Whatever solution or whatever tools that are selected for building the solutions, they need to be future-proof. So you need to make sure that they are flexible, they're extensible, and if you're going to start an initiative today, you don't want to lock yourself in for the future. And then there's a need to do things efficiently. There's a need to add quality along the way, and we'll talk a little bit about that when we look at the approach that was taken. So at the start of the project, so in the early stages, this is the target architecture that DC had. There's a number of systems in the horizon here which we haven't included, but ultimately there was a need for having a automation engine which would talk to the network, and this was going to be the central point to interact with the network itself. There was a need for a MOP orchestration engine that sat above it to interact with the third-party systems. And also, there was a very, from the onset, there was a very conscious effort to leverage continuous integration, continuous deployment as part of whatever architecture we were envisaging. Obviously, we're here because the tools that were chosen were Itential and NSO. And after a number of processes and reviews, we kind of satisfied a lot of the requirements here. The service areas in this diagram, by the way, so do you want to talk a little bit about what your service areas?
Yeah, sure. So a service area is basically our part of in the German Deutsche Telekom network where we host different applications. So that's basically the data center part where we have located IMS or our customer databases. So it's a LAN automation project. So yeah.
Okay. So the general approach here is, I think it's a recipe for success. When I first started engaging with Deutsche Telekom, I remember the early workshops. I remember being in the conversations where the team were very adamant in the way they wanted to approach this entire project. And I have to say, having been in this industry for 20 odd years, it was refreshing. It was like finally someone's getting it, and a lot of this was reflected in the talks that were given yesterday. So when we look at the first column here, we look at quick wins. And this is so important. I mean, the whole walk before you run is really relevant here. Selecting the use cases that give you the biggest bang for your buck is, it's a no-brainer, but it's so often missed. So often people just try and boil the ocean, and then they wonder why things don't work. So to hear that, Deutsche Telekom wanted to look at deploying the solution in a way that was, going to show very, very quick and obvious impact was a good approach. And then choosing the use cases to help them do that, again, I think this is where they were successful. There's the ambitions and the aspirations for automation in DT are big, but you then kind of roll it back to say, like, what can we do quickly to demonstrate that we've chosen the right technology to solve the right problems? And typically, we've seen things like maintenance work is a no-brainer, because maintenance activities are, they're never ending. You guys are all doing this today. A lot of you will be doing this manually. So to try and take a maintenance activity like a software upgrade use case and automate that activity, it ticks a lot of boxes on the quick wins. And that's what was selected. So we selected a couple of software upgrade use cases, and again we selected some very specific service areas in which to try these out. So rather than trying to upgrade your entire 70 odd service areas, let's demonstrate that these things work and work well in a very specific controlled area, and then we can scale out from there. Second thing that I really liked, and coming from a software background, I mean, this was great to hear. Using software development best practices to roll out an automation project is, again, it's a win-win. And what we're trying to do with automation has been done for the last, God knows how many years in software development. The whole notion of continuous integration, continuous deployment, that comes from software. So rolling these principles into building solutions for network automation, I think that's if you start off with that mindset, with that goal, it'll be hard to go wrong. So looking at the best practices, we talked about collaboration, and collaboration is key. And when we talk about collaboration, again, the thing that struck me in that first few sessions that we had is we had teams from engineering, from operations, IT representatives, program management, Cisco CX were there, Itential were there. It was a pretty big team, but everyone was involved and everyone was getting brought into what it was we're trying to achieve. So if you can involve the various stakeholders from the onset, and you can convince these guys that what you're trying to do is for the benefit for everybody, then they'll buy into what you're trying to do, and that buy-in will really go a long way in how successful you will be, because you need to involve all these people as part of the entire process. And then using things like Agile. So Agile is a heavily used term nowadays. Everyone's doing it. Everyone wants to do it. People do it to varying degrees of success. For software development, I like it. For building solutions, I think it's really good. And what we've seen over the last 3-4 months is, using an agile approach to build your solution is so important. I mean, the solution that we've built today is, it doesn't look like the solution that we talked about 3 months ago. And, it's better. And the reason it's better is because the team who've been building these things together have been able to demonstrate, regularly, every 2-3 weeks, the progress they're making, so that the stakeholders, these are all the people that have a vested interest, can feed back and say, actually, it's not quite what I thought about when I mentioned this initially. Do you mind if we change this, that, and the other? And we do need to control the level of change, but we need to provide the opportunity and the framework in which this change can occur. So, I think the solution that we have today is far better because of it. And then looking at the actual development, how do we develop these solutions? Because there's many ways you can do this. Using a modular development approach is important. Now, one of the things that was made clear from the onset, and we talked about yesterday, there was an analogy of, do you want to come to the Cisco restaurant? Do you want to come cook with Cisco, or do you want to cook it yourself? It was clear from the onset that that Deutsche Telekom had an aspiration for building the solutions themselves using the technology that they've chosen. So the way in which the solutions were built was important in this because we want to enable the team to be able to do this themselves, but we want to instill the best practices in the way we do it as well. And this all ties into the above. The collaboration involved in the team included, Johannes is front and center in this, and it included Johannes being present and guiding the team in what they wanted to build. And then the team built it in a way that was very reusable, it was modular, having things that can be used down the road, with the awareness that this solution isn't a point solution, it's one that needs to have a strategic life, means that to use an analogy of the cooking things, we were helping to build the sauces that can be used in other recipes once we've left. And that's really the goal here. So, to be able to build things in a way that we can hand over and the team can continue to leverage those in future use cases. And then the CI/CD, again, I mean, having that in the architecture on the RFP stage spoke volumes. You're declaring your intent, saying, I want to try and use automation to help validate what I'm building is of the quality that I want to do. And then the third column was an interesting one because you can build an automation solution to solve a number of problems, but you can do this in many different ways. If you don't think about the end use case and the operational use case of why you're building the solution, it doesn't matter how good your solution is, you will always get resistance. You will always get people not wanting to use it, because if you can't operationalize this thing, then you're just fighting the next journey. So thinking about the operational ease of use up front will help drive the way you build a solution. It will help ensure that you've always got the perspective of the person that's got to drive the end product. So from the onset, it was made clear that there needed to be an ability for controlling all network changes in whatever solution we built. We ended up providing a means of presenting summary screens and post-mortem reports in a very clear and concise way, so that it would make that team's life easier for when things go wrong. And as we can try and get things working all the time, but we know that things will go wrong. So you can't bury your head in the sand here. And then basic things, right? So implicit AAA integration. So this is all about if I'm onboarding new devices, how can I automate the entire process so that I don't have to automate a subset of this and then have to do a lot of things manually to try and get to where I want to get to. So when we look at the software upgrade use cases, we look at what's typically needed for this type of this type of use case. Now these categories are, they're pretty high level. When you want to roll out some new maintenance activity, you need to plan it. You need to make sure that the relevant software is available. You need to make sure that it hasn't corrupted along the way. There's a lot of pre-tasks, and then there's the preparation of actually, before you run the upgrade, is the network healthy? Is the device healthy? There's a lot of pre-checks that are necessary. And then you execute the upgrade. So this is actually performing the upgrade. You then return to service and you close it out. Now, traditionally, when people look at automating a software upgrade, this is what they focus on. So you look at the execution part, and that's where a lot of time and effort is spent. However, when we look at the actual effort involved in the different tasks required for upgrading the device, the actual execution is a fraction of the overall effort. And these figures are based on things that we've seen. I mean, if you think about the time spent preparing and returning to service, why automate just that 8%? Why not pay for the end-to-end? And that's what we ended up doing here for the DC project. So the boxes that we've seen here, again, it was mentioned yesterday, it's very easy for us to draw these boxes and draw the flows. Behind each box is significant effort. There's a lot of different things that happen behind each box. At a high level, this is the process that we've implemented in the solution. The diagram on the right is the service area. So the service area is it's an HA topology, so there's a high level of redundancy. So when it comes to upgrading the devices, we want to do this in a way that can upgrade each pair. So the first thing we do is we identify the devices, check the versions, upload and verify the images, making sure that the health of the entire service area is sound. And we do this by integrating with the alarm systems that are in place. We then look at the individual device and check the health check. Taking a snapshot will allow us to then compare this down after the event. We then isolate the device so that it doesn't receive any traffic during this process. You then perform the actual upgrade, so that's the actual 8%. So that's just one little task. Once the upgrade is successful, you can verify that everything is as it should be. You de-isolate the device to return traffic, take another snapshot so you can compare, run the post checks, and repeat for the second device. So these are all high-level bullets that we wanted to try and cover. And what we want to show you now is a demo of this use case, and this is something that we pulled out of the solution last week. So this is a demo of the actual solution. We have we're using simulated devices to upgrade the simulated device, because a real upgrade, I'm sure you guys don't want to sit here for the next 30-45 minutes watching the upgrade happen. So I'm going to hand over to Johannes now, and if we flip over to, there we go, and we're going to take you through the actual solution.
True. Do I have to end the show again? Because I'm not seeing the. Okay. So there we go. So that's a Itential platform. Not sure if everyone is familiar with that, but that's basically where all the different applications are located, where we can develop these workflows, everything else that goes into the workflows, and then also to start the process. So we find these in Service Catalog, and it's basically a location from where we can start our upgrade. And the Service Catalog ties together a form which basically starts the workflow, which gives us some more options to specify parameters that are used in the upgrade. So some timers we want to have different kind of flags we can set, what kind of configuration we want to apply during the upgrade. So in the specific upgrade we are doing here, it's from a Junos version 14 to 17. So there's some configuration which becomes mandatory after the upgrade. So as part of the upgrade, we have to perform these configuration items and some more items there. And I think what we have hidden there is a lot more information which goes into starting the upgrade. So information about from where to download the files, what kind of timers do we want to have in NSO while the device is rebooting, so we don't lose connection, all these kind of things. So we can, and we also have a flag we can set to just say, okay, we want for now at daytime probably just stage the image, download the software image, and then for the night shift we don't have to do it at night because that also takes some time. Okay, so once we start the workflow, we go into our active jobs. And the first item Annand mentioned is we have to select the devices we want to actually upgrade. And the approach we took there is not having someone type in the exact device we have here. So we can select an environment. So one service area type. This is defined basically by the service area type. So what kind of applications are hosted there? And what kind of network setup do we have there? And also the name to uniquely identify the environment. So this information is taken from NSO. We had on the architecture slide, we have the parameter database or CMDP part, which is not ready quite yet for the project. So what we did is we are leveraging NSO as like a topology light inventory here. And we have information about these service areas, which devices are located there, how are they connected. And what we also have in NSO is to specify different software versions, what kind of files need to go in to upgrading these. So we know how to verify them later. We can use this information to tell the device to download the correct files and also to verify the images. And this can also be used to then for all kind of different devices. So we are not bound. That's what Annand was also saying, speaking to modularity. The screen we can always reuse. We can just introduce more device types. We can tie this into our system engineering. They can specify which software versions are actually validated, and then we can choose from there for the upgrades. What we also can do is just to make this a little bit more future-proof, we have some points in the workflow where we can basically tie into and just put other workflows which we want to run at these points, just to make this a little bit more adaptable. Okay, so, and we can't start as it's needed at Deutsche Telekom. We always need a change number. So we also made sure you can't actually do something without a change number. So we can just specify one and proceed. And what the workflow is now doing, it's looking in our topology data that's in NSO. So we are fetching the data. We are checking which device names are there. We are getting all the different variables we had in the form and also the hidden fields. So we can then use them during the execution of the workflow. And we should get back in a second the devices that are actually applicable for us to upgrade from the topology. There we go. So we now got the cross-connected devices which are located in that environment. And we can just select one device and it will always just take the pair. So we are always making sure we are upgrading the correct pair and not mistyping anything for the devices. So continuing along with the workflow, we are now preparing a lot of stuff, actually checking on the different devices. Is the software already there? Then we don't need the upgrade, so we can just stop the whole thing. Also just determining which of these devices is currently active path. So we have always redundancy, so we have an active and a passive path for most of these devices. So we are now taking information from the topology model, which interfaces to query for this traffic information. So And this way we can determine, okay, which device do we want to go first, and we'll soon see a screen for selecting this or proceeding with the upgrade. But what we can also do is just take a quick look what happened to our pretty little slide with the workflow. And that's basically all the boxes which go into just preparing the overall data for the upgrade. And then maybe just for the people not familiar with Itential, so all of these purple boxes, they are basically data manipulation. So we are fetching data, we are manipulating data, evaluating data. The green ones are automated tasks, which are run, and they call different applications inside of the Itential platform. And then we have the blue parts, and what you will already notice is we have quite a few blue parts still left in our workflow. And that's mainly to build trust with the operators, to make sure we can then, for the workflows we are running now, or the first use cases, we can double check what is NSO and what is Itential doing, and then to build confidence in the technology moving forward. And this is then some of the purple parts are also sub workflows. So this is just the top level workflow, and we are calling 4 different ones. So during the whole execution, and we will see that popping up here. If you pay close attention, there will be like a second level for the drop down. Okay, so I think we can proceed. Yeah, we detected, okay, the current software version is older than a new one, so it makes sense to actually upgrade. And what is happening now is we jump or we create some more information, and we should soon jump into the upgrade workflow. So this is our child workflow, which then does all the pre-checks, post-checks for the actual upgrade. So we are now collecting information on the devices. We are performing health checks, which we are saving. We are performing the snapshots. So for example, which interfaces are up and running before we do the upgrade. So after the upgrade, we can take the same snapshot, compare, and immediately see if there's something we don't expect going on in the network. Yeah.
So one of the things to point out here is for the operational ease of use. So the workflow itself is quite complex. Now, one of the things that we want to do is provide the operator options throughout the lifecycle of this upgrade. And if I will see an example here where the software image that we want to upgrade to doesn't exist on the device, and in order to do this, we can build the automation so that it can automatically just fail or continue. But by providing this kind of feedback loop, and doing so using warnings, errors, or just information, it kind of just allows you to build a solution that down the road, when you want to go back and see what happened, it becomes a little bit easier. And again, this is all things that relate to what's the operational experience that you want to provide, and having to think about that up front means when you come to build a solution, you can build it as part of the foundations, and that's some of the things that we've done here. And you'll see a lot of tasks that are taking place here, and the reason for those tasks is making sure we're capturing the right data at the right point so we can provide the information.
Yeah, and also this whole display part is just another sub workflow. So you don't have to take care of every single time you want to display something, a warning and information. This is just calling a different workflow which takes care of the reporting. So just now we encountered an error, totally expected, because we don't have our alarming system here. So we will get an alarm about not reaching our SAVIX instance. So if an operator sees this, you can check, okay, why are we not reaching the alarming system? Is this related to the device? Is this related to the alarming system? And so we know why this is happening, so we can just proceed with the workflow. What we are then doing is also checking on the device, are there any active alarms? Currently we don't have any, so we can, to save time, skip this. And then are, I think, pretty much in the last stage before we are actually starting the upgrade. Yeah, so it's just now taking the snapshots, checking, okay, did we actually get it, snapshot, all these kind of checks.
So one of the additional thing in terms of automating the pre-checks is being able to execute commands that would typically be done by hand. So one of the things that are added into the process is the mop automation, and being able to define the commands and the responses that you're expecting in a mock template will allow the whole process to run automatically and determine itself whether it can succeed. And I think DC had 20 plus commands that they wanted to check as part of the pre-checks. And again, trying to automate all these things is where the complexity is, and one of those little boxes results in 20 odd different checks that need to be made.
Yeah, so the way we specify different commands which are part of the mob, all the traffic to the devices always goes through NSO, so we have all the RPCs exposed by the net or show commands available for the devices. And we can also then specify rules. Okay, what is the criteria to pass these kind of tests? So we can just do simple matches. We can do regex and some more sophisticated stuff we don't have used here. But just to give you an idea how this then works for the implementation. So I just made a small error, which is perfect for demonstrating why it's important to automate this. So I totally forgot we need to isolate the device. So I just now said, okay, we're ready for the upgrade. And this can happen if you are doing this manually and you're following your Word document where you have 100 pages of different commands you have to execute. So you go over a page or something. If we have this automated, this doesn't happen. So for the device we want to upgrade, we fetch data from a topology model to find out, okay, which interfaces do I need to shut down to isolate the device from production traffic. What we see here is a commit try run from NSO. So we see for the different interfaces, which interfaces would get shut down. But we also augmented this with information for the description of these actual interfaces. So if you are sitting in front of the screen, you have actually an idea what is going on. Because with the interface names for most of the devices, you don't really know what's behind it. So we can kind of judge, is this what we are expecting, or is there some interface in there which we are not expecting during the isolation? So once we have isolated, we should have the last step in front of, or before actually proceeding with the upgrade, yes. So after isolation, we also want to have the opportunity just to check back with the application operators. By isolating device, is the service still healthy? So we just have another manual stage in here currently, just to confirm, okay, this is all going expected. So a lot of these manual tasks can just be removed once you have more confidence in the solution, but also more experience with implementing these and kind of know what we have to focus on. So currently the device would be rebooted, and for that we implemented like kind of a health check or checking if the device comes back. We are so pinging the device basically with an RPC, not to have like an IP ping and then the actual daemons and the routing is not up yet. But like an RPC goes down via NSO to see, okay, is the device actually back? And then we are performing, again, de-isolation. We are taking another snapshot. We can then take a look at the difference between all the command or the before and after for all the commands we executed. We can take a look, and we also get a little highlight where did we have a mismatch. And we can then have a visual diff representation for the different outputs and see what changed. So Right here, this is demo data, so we just changed the software version, but you get the idea. And the same thing we have for all the health checks we performed. So we will, in a second, we are now performing the health checks, and then in a second get a similar screen just to compare the different outputs. No mismatches there because just demo data. So okay, so the first device is now upgraded, so we are now fetching data for the second device, but we can skip that for time reasons and also to save lunch for everyone. Then we can take a look at our summary task Annand already mentioned to get like kind of a post-mortem where we augmented the Itential platform with our own application to see, get a bit more information of what was going on during the change. So we are now recognizing the software version on the second device is also different, and we'll soon be able to specify that we want to abort here. And we will get a summary of the entire upgrade that we can take a look at. So the overall status, get just a quick screen what was going on, and then for the different, so these are all the different workflows which were run, and they have an overall status which just compounds from the different states we have in here. So all the stuff we did for upgrade, for transferring the image, and then also for all the stages where we did pre-post checks. So for example, we didn't find the image, so we had to upgrade the device. And we can also email this information because email is awesome. Everyone wants their report not in the tool because then you have to somehow access it, but you can also have it in your inbox. All the data that was shown here, the overall status. Also, which devices were upgraded, the change numbers, everything you need to actually identify what the actual event. So I'm not sure, do we have the notification for email? Or oh, there we go.
Yeah, so if you go today, there you go.
There we go. So we get an overall status at the top. We get the devices. We get the state for the both of the devices.
Pictures, you might see Tommy on there as well.
Sure. Yeah, there we go. Okay.
It's the
important part. Yeah. We also get the workflow ID inside of Itential. So if you need to dig deeper in the internal data, we get the way to correlate that, and we get our change number. Then again, overall status for the different parts that we're on. So we can also have this information, or we also have this information available in the application. So we built, it's easier to show on home screen. AUTLAN is not part of the project or the product. So we built, the Itential guys and built a custom application for us to get more insight of what is going on in the job manager, to make the data available, all the summary data we have available in a way that our operations colleagues can actually work with them. Because if you saw all this, you saw all the execution on an Itential task level, but that's not what the network device operator wants to work with, because there are, I think 11 pages of tasks which were run there. It's not easy to get an overview, okay, where did something go wrong or not. So we have the opportunity to filter for the change ID for the different devices. And we can just take a look again at all the tasks where we had to actually do something. So we can take a look at what environment did we choose for the upgrade, or we can check again, was the isolation process performed correctly, all these kinds of things. What we also have is because NSO doesn't always cover the entire configuration for the devices, we also perform like a backup for the configuration we have on the devices, so pre and post of the upgrade. So we have the actual full configuration, which is a little bit more than the sync from for most of the devices currently. So we also have that available if something goes wrong. Yeah, I think that's for the demo. Yeah. Okay, so
we flip back to the slide. Okay, thanks, Johannes. So, very quickly then, I just want to touch on the CI/CD work that we did as part of this project. So, as you saw, it was planned in from the onset, and this is the pipeline that's been created. And in fact, there's a talk at 2:00. I think Arthur, who was working with us in this, he's going a little bit deeper on the NSO side of this. But this is the pipeline that's in place now. There's still work to be done on some areas, but in essence, we've got Jenkins, which is managing the whole process. We check out the solution code from a Git repository. A lot of the artifacts are in Artifactory. Once the artifacts have been downloaded, we set up our Docker containers. So we run the Docker compose files, attach the various volumes, and we start Docker. So in this project, we had a container for NSO, for Itential, and some of the additional components that Itential needs. So we had a container for the Mongo database, for the Redis database, and raster is the test framework that's included as part of the CI process that the Cisco CX team built. So we had a container for that. Once the containers are up, we configure Itential, we deploy the necessary packages that allow Itential to work with NSO. We set up NSO, we install the nets, set up the netsims. Eventually we'll configure NSO, load the data, and we're at the point where we're ready to run the test scripts. And again, as part of the whole agile process, developing automated testing is critical. Again, going back to the software development best practices, I can't, it's still how important it is to write some test automation, because this will, no matter how much time you think you're saving by not doing so, in the end, you're going to save so much time if you have some level of automation to test your solution. So, plumbing those test scripts into the raster framework will very quickly and very easily show us what works, what doesn't work. If everything's great, then we'll publish results either way, right? So we publish the results to update Jira, send an email. There's still some work where we want to integrate SonarQube as a static analysis tool to perform some essay on the solution, and eventually release this back into Artifactory. So this is what's in place. A lot of this has been done. There's still some work to finish this off.
Yeah, before you go, that's maybe one already lessons learned. We heard earlier today, plan this from the start. So Annand said this was part of the RFP, this was always planned to do. And then it got kind of reprioritized during the project. And now we have our first use cases running. And now we actually need this to see if any modifications we need to take care of or to profit of all this modularity. We can't test automatically fully yet. So a heads up there, don't reprioritize around CI/CD, get this finished, get this done, and then work from there.
It's so important, and don't underestimate the effort, right? Because these things, you do need to plan it out, you do need to resource it, right? When we did all these, it's easy to draw a box on a slide. Behind the box is a lot of work. But when it comes to the benefits you're going to get from putting this in place, you will see it down the road. I can guarantee that. And then next steps. So the use cases that we saw here, we've got one of the use cases has gone through ATP a couple of weeks ago. There's another use case which hopefully we'll get through ATP this week. And then these will be rolled into production in the coming weeks. There's obviously some work to complete the CI/CD process, and then the team will start looking at additional use cases. So there are generic connectivity use cases that we need to look at, and these are things that the team will now will start kind of handing over these back to DT, and hopefully they'll be able to pick some of these things up themselves. There's additional software upgrade, so there's a lot of other devices that we need to ensure we can upgrade as part of this process. zero-touch device onboarding provisioning. I mean, everyone needs to do zero-touch onboarding, right? So this is another use case for that, so is very relevant. And then the bottom one, you saw that initial architecture slide, lots of different systems, lots of integration points, and if we're really benefiting from automation, you want to get the end-to-end automation, and that's the goal at the end there. That's all we had.
Cisco, the bridge to possible.